Hello, friends. Good morning and good evening, everyone. How are you all? Welcome back to our channel, ALP Talks YouTube channel. After many days, I am with some more videos again. So, what's going on? Let's go ahead with today's topic. Learn electrical with us day by day. Small topics. So today I am with one topic on electrical system. How power generation takes place, how power utilization takes place, how the power transfer between generation to utilization takes place through transmission system, distribution network, and all. So let's go ahead. Small, interesting topics will be there. Enjoy those things, and you will sharp your brain. Okay, let's go ahead. Let me share the screen. So here you have many things like you can see power generation, transmission, and distribution, utilization, everything. So you have a lot of things here. So for example, you have power. You need power, right? Without power, how we will assume yourself? Let's say half an hour power cut is there. How you will behave? What's your mental stress? Okay. So we can't imagine our lives without electricity. That is sure, and it is proven thing. Okay. So let's understand about it in a better way. Say there is some generation, electricity generation, and your house is far away. Your house is far away, and you need power to feed your house, right? Why? Why you need power to feed your house? It's required to feed your stomach. You need water as well as food, right? Food you need. These things you are arranging somehow. What about electricity? You have many devices, right? Let's say you have mobile phone in your house. You have mobile phone, and you have light. You have a TV. You have fan, ceiling fan. You have AC. You have a refrigerator. You have many small electrical items in your house. So how it will work? It's with electricity, right? You need power to feed those electrical devices. So where you will get the power? You have a nearby electricity pole. So what you will do? You will get power from those lines. Mostly single phase power is used for households. Of course, three phase power also will be there. We will discuss those things in the coming days. Okay. So when you need power to feed your house, all the electrical devices, it's good. Somehow people are generating power, somehow you are utilizing it. So what happens in between this generation to the transmission? You can see here, this is your house. This is the generation. You have many power plants like nuclear power plants and hydro power plants and thermal power plants. Nowadays you have solar and wind. Like that, there are many sources of generating electricity. Many ways we are generating the electricity power, and we are going to use it. For example, if you have a generator with your house, you can simply use it, right? You can turn on, it will generate power, you can use it. That's nice. Okay. Then what is the case if your neighbor needs power from your generator? What is the case if your neighbor village needs power from your village? What is the case? Some village, 5 villages after your village, it needs power from the. So it is possible through these electricity network system only. Okay. Lot of systems will be there in between. Big electricity network will be there. Power lines will be there. Transmission lines will be there. Transformers will be there. Electrical components will be there. Many things will be there. We will see those things in the coming days in a detailed view. Okay. So somehow you are getting power. Let's discuss few more things here. For example, let me show some another snap here. Say you are here. Utilization, generation, everything will be there, right? For example, utilization is required. So utilization is there, generation is there. For example, here generation is there. Okay. And you have utilization here. So you have many houses, people are going to utilize it. So How this power is transferring? I just shown like with the transmission lines, towers, and other distribution network, transmission network, we are transferring the power. So if you need food, how much time it will take for Zomoto people or some other Swiggy or someone to deliver food for you? How much time? They may take 30 minutes to prepare, maybe another 10 to 30 minutes to deliver, right? It is in transportation. So if food is to be transported to your place, right? You are here. So it will take 30 minutes to 60 minutes to reach you. It may be quicker, it may be a little bit delay. What about electricity? What about electricity? For example, you turned on, you have a lamp in your house, you have a switch, you just turned on it. How much time it will take to turn on it after you press it the switch? It's instantaneous, right? If it takes over, if it turns on after 5 minutes, after 10 minutes, then what is the case? How you will behave now? It's taking 10 minutes or 5 minutes time to turn on the light. You will fed up, right? But what is the case here in food case? Because it is 30 to 60 minutes it's taking. So it what here in food case they prepared sometimes back and you are consuming at the end. What about electricity? They generated sometimes back? No, no, no. There are some cases, so we'll see those things again later on. We will make this concept more generalized way. For example, you are here, you are here. You need 100 megawatt of energy to feed all the people in your country or place. Then there is a rule that 100 megawatt needs to be generated. Of course, let's consider losses and everything, and otherwise let's take an ideal case where losses are zero. Okay, so 100 megawatt will be generated. So when this 100 megawatt generated, the question is here, when it is generated? Half an hour before, 1 hour before, few hours before, or a few days before, or few weeks before, when the power is generated before coming to you. Here, the things are instantaneous. For example, you need power. If you switch on, it is coming, right? Electricity doesn't need time to travel. We can't say like that. It needs some time, but fractions of microseconds. For example, this is a globe. Let's say the electricity takes fractions of second to to cover the entire globe Earth one round. Okay, that is the speed of electricity. It can reach you very quickly. So you can't see those delay with your eye. Okay, so if you need power, the time you are switching on it, the same time the power is getting generated there in the generators. Okay, so it may be coming from different power plants. It may be Sri Salem hydro power plant, or Ramagundam thermal power plant, or it can be some other site where with the sun they are getting the power. Or it can be other place where with the wind they are getting power. It doesn't matter for us, but it is generating at the same instant, almost similar time. When you need power, at the same time it is getting generated. Oh, if that is the case, if you turn off life, if you turn off your light, what happens? They will turn off generator. Your light is very less, small quantity, right? It will consume very less power. They don't turn on directly the generator. They will switch over other lines. Okay, they switch over other lines. So, say if you need 120 megawatt immediately, what they will do? They will increase the generation. If you need 80 megawatt only, because you are not using power, they will reduce the generation. How things happens instantaneously? We have speed governing system, all the power plants in where turbines are there, and in all other solar or wind or other places also we have governing systems to take care of our power feeding, how much power is required. There are huge penalties also if you didn't met your promise. For example, this solar plant told I will give 50 megawatt, but somehow due to some issue they didn't produce, so they will be penalized for that. Like that, strict guidelines will be there. how much you need, that much they will generate. They will have clear-cut list. This much power we need for this day. This much power we need for next day. This is the planning actually. Similarly, as per that plan, they will produce the power. All power is instantaneous. Okay. There should be equal balance between power generation and power utilization. Okay. You can see this is the cube, right? What happens if one side is not balanced? It will fall down. That what happens? Stability should be there. Grid stability should be there. Voltage stability, power quality. There are number of things, number of concepts involved. We will discuss those concepts in the coming days. One topic a day. Okay, we will discuss those things in a detailed manner. So the thing for today is this is how the power transfer takes place from generation to the utilization. It is instantaneous. Whenever you need power, they are generating it. Whenever you don't need, they will shut down. That's what happens. Okay, and they may turn on thermal power plants. If you need power, if you need a load after half an hour, they will turn on thermal power plants now. Why? Because it takes some time to produce power. Because it is heating, right? Coal heating, it takes some time. What about solar? Morning also power will be less due to low radiations. Afternoon the production would be high. Evening again it will be low. What about wind? We can't say. What about hydro? Based on water flow, of course we are storing water, so we can still maintain power. So they will use certain power plants base load like nuclear power plants, maybe hydro power plants. Some power plants, so certain power plants they will use it for base load because they can't turn on, turn off, turn on, turn off. They will make it as a base load. And there are certain power plants, they will run when required. For example, you need 20 megawatts additionally in next 10 minutes. We will run gas power plant where gas we are using for generating the power. You can't run coal power plant by the time because it takes half an hour. So coal would be your base. Nuclear, we can't start it again, right? Once it started, that's it. So nuclear also base load, it will feed. Peak loads point of view, we will have other alternatives like hydro or gas or some other. We can use it for a peak load purpose. Okay, this is how the network works, guys. Electricity distribution system. This is how it works. And thank you. Thanks for watching. I hope this is a lengthy video after many days. And still, I hope this video is useful to you. It might give in some good information to you. And if you have any questions or comments or anything, do comment in the comment section. And my WhatsApp and my other professional network details are available. Do connect with me. And if you have any questions, post to me. I will try to clarify those. And we'll do these kind of videos in the coming days also. Do subscribe to this YouTube channel, ALP Talks, and share to your friends and others. Do like this video if you enjoyed it, and also go through our space again on all social media platforms with the ALP Talks handles, and do watch our previous videos also. And if you have any professionals who want to share their knowledge, let us know. We will interview them and we will share their experiences with you so that it can benefit you. Thank you. Thanks a lot. Signing off today. Bye.